Cedar Studio provides tool support for devising adaptive model-driven enterprise application user interfaces based on the Cedar architecture. In this video, we give a brief overview of Cedar Studio and demonstrate examples of adaptive user interfaces with multi-aspect trade-off. We are now observing the task model of a bank account user interface represented as a concar task tree. The second level of abstraction is the abstract user interface model that represents the UI independent of any modality. The third level of abstraction is the concrete user interface model that represents the UI in terms of concrete widgets. Cedar Studio provides visual designers for all UI models and supports automatic generation between one model and another. Currently, Cedar Studio supports two types of UI adaptations, namely feature set minimization and layout optimization. Feature set minimization is accomplished by allocating roles to tasks, hence achieving a multi-layer user interface design. Layout optimizations, on the other hand, can be implemented as adaptive behavior workflows that combine both visual and code-based constructs. To balance the trade-offs between conflicting UI adaptation goals, we devised a technique that combines goal models, ghost functions, and Pareto analysis. We are now observing a goal model that represents three fuzzy sub-goals of usability: adapt to medium vision user, novice user, and tablet user. These goals represent the adaptation aspects and are realized through operations, which could also be refined into sub-operations. Each sub-operation is assigned a cost for each of its related fuzzy goals. When the system faces conflicting goals, a Cartesian product of the possible operations is computed, and a cost function is applied to all Pareto optimal elements produced by this product. This cost function is also parameterized with aspect weights. Furthermore, sub-operations are associated with adaptive behavior workflows that can be executed at runtime to realize the adaptation. We are now going to observe the bank account UI with adaptive behavior and multi-aspect trade-off. The UI we are viewing is the least constrained version of the bank account user interface. We can easily adjust the weights of the aspects that we observed in the goal model in order to obtain a new user interface that is optimized for the given configuration. If we set the weights of the aspects to be 2 for the novice user, 3 for the medium vision user, and 1 for the tablet user, we can see that a large font size is selected. The combo boxes are switched with radio buttons, and the higher accessibility of functions is given. If we set the weight of the tablet user aspect to 3, and both the weights of the novice user and medium vision user aspects to 2, we can see that the widgets are grouped using tab pages instead of group boxes in order to save space. A medium font size is selected, and the radio buttons are switched with combo boxes. If we run the same UI with a different user, we can see that the feature set has been minimized to meet the selected user's needs. Similar to the previous UI, aspect weights could be adjusted to obtain an optimal layout. The ability to assign aspect weights allows easier high-level customization on handheld devices in evolving contexts. We are now observing a mobile version of a business partner's UI based on that of the SAP ERP system. This UI provides a lot of details and is suitable when the user is idle. Yet when the user starts walking or running, the aspect of mobility has to be augmented over that of detail. We can see that with a simple accelerometer-based gesture, the user could increase the weight of the mobility aspect in order to get a UI that is more optimal for the given context. The UI's feature set in this case is minimized, a larger font size is chosen, and the higher accessibility of functions is given. A different gesture could augment the weight of the detail aspect, hence changing the UI back to one of its previous states. In this video, we demonstrated how Cedar Studio could be used for devising adaptive enterprise application user interfaces with multi-aspect trade-off capabilities. If you would like to find out more, you can visit our website.